Ever wondered how data travels through a network and how we can optimize this flow for efficiency? Well, this intriguing journey is all about network flow problems. These problems are like puzzles that mathematicians and computer scientists love to solve. But why should we care? Because they're everywhere. From managing traffic flow in bustling cities to ensuring smooth data transmission over the internet and even optimizing supply chain logistics, network flow problems are at the heart of many real-world scenarios. And there's this interesting concept of maximum flow minimum cut theorem. Without diving too deep, it's a principle that helps us solve larger-scale network flow problems more efficiently. Sounds intriguing, doesn't it? Trust me, understanding network flow problems can be as exciting as it is vital. It's like being the mastermind behind the scenes, directing the flow of information, goods, or people to where they need to be. Now that we have a basic understanding of what network flow problems are, let's delve into how we can solve them. Solving a small-scale network flow problem might seem challenging at first, but with a clear understanding, it becomes a piece of cake. Imagine a small town with a water supply station and several homes. The water station represents our source, the homes are our sinks, and the pipes connecting them are the edges. Each pipe has a maximum capacity of water it can carry, just like in a network flow problem. Each edge has a maximum capacity for flow. Now let's say the water station has a water pump that can pump 100 liters per minute, and there are 3 pipes leading to different parts of town. One pipe can carry 50 liters per minute, the second can carry 30 liters, and the third can carry 20 liters. This is where it gets interesting. The total capacity of the pipes is exactly 100 liters per minute, the same as the pump's capacity. This means that all the water being pumped can be distributed without any problems, right? Well, not exactly. This is where the concept of flow comes in. Flow is the actual amount of water, or data or traffic, depending on your network, that's moving through an edge at any given time. So, even if our pipes have a total capacity of 100 liters, the flow might be less if, say, one of the pipes is partially blocked, or if not all homes are using water at the same time. And this is the crux of a small-scale network flow problem. We need to ensure that the flow from the source to the sinks doesn't exceed the capacity of the edges. At the same time, we want to maximize the flow to make sure as many homes as possible get water. See, that wasn't too hard, was it? But what happens when we have a larger network? For larger network flow problems, we have a secret weapon, the maximum flow minimum cut theorem. Now you might be wondering, what's this fancy theorem all about? Well, let's break it down. The maximum flow minimum cut theorem is a fundamental concept in network flow theory. It's a bit like a superpower for mathematicians and computer scientists alike, helping us solve larger, more complex network flow problems that might otherwise be quite daunting. Imagine a network as a series of roads connecting various cities. The maximum flow part of the theorem is all about finding the greatest amount of traffic that can move from one city to another without causing a traffic jam. On the other hand, the minimum cut part of the theorem helps us identify the smallest number of roads we would need to block to stop all traffic between 2 cities. It's essentially about finding the weakest link in the network. Now, let's consider a simple example. Imagine a network with 4 nodes. The maximum flow from the source to the sink is the sum of the capacities of the outgoing edges from the source. That's the maximum amount of goods, information, or traffic that can go through the network from the source to the sink. And the minimum cut? That's the smallest number of edges you would need to remove to disconnect the source from the sink. In our example, it might be just one edge or road. So why is this theorem so important? Well, it provides a powerful tool for optimizing network efficiency. It helps us understand how to maximize flow while minimizing potential disruptions, which is crucial in fields ranging from transportation and logistics to telecommunications and computer networking. And the best part? The theorem guarantees that the maximum flow and minimum cut are always equal. So, once you've found one, you've got the other. With the maximum flow minimum cut theorem, solving large-scale network flow problems becomes much more manageable. Let's quickly go over the key points we discussed today. We started our journey with an introduction to network flow problems. These are mathematical problems that involve optimizing the flow of a certain quantity, like goods, people, or information, through a network. This network could be anything from a series of roads, a computer network, or even a pipeline system. So you see, this isn't just a mathematical concept, it's a tool we can use to optimize real-world systems. We then dove into small-scale network flow problems. These are simpler scenarios with a limited number of nodes and paths. We can solve these problems by inspection, which means we look at the network, analyze the flows, and determine the best way to optimize them. It's a bit like solving a puzzle, where you're trying to find the most efficient way to move your pieces from one side to the other. This brings us to the maximum flow minimum cut theorem. This theorem is a powerful tool that aids us in solving larger-scale network flow problems. Essentially, it tells us that the maximum amount of flow that can pass through a network from a source to a sink is exactly the same as the capacity of the smallest cut of the network. In simpler terms, it means that the biggest amount of stuff you can move from point A to point B is determined by the narrowest part of your path. So why is all this important? Well, understanding these concepts can help us make better decisions and plan more effectively. For instance, if you're a city planner, you could use these concepts to design better road networks. If you're a computer scientist, want to rise to your full potential in your studies and revise like a boss? You can trust Study Guide today to have you covered. Subscribe to this channel and see our website linked in the description of this video to see revision articles to maximize your study gains.